Hello, everyone. Thank you so much for joining. I'm Dominic Williams, founder and chief scientist of the Dfinity Foundation. Dfinity is the leading contributor currently to the technology of the Internet Computer blockchain network. The Internet Computer is a revolutionary public blockchain. It's the first to be infinitely scalable. It's the first to run at web speed, and it's the first that enables smart contracts to answer HTTP requests and serve interactive content directly to end users, amongst many, many other new advances. So this is going to be a new series where I bring you into some of the development processes that take place at Dfinity and answer community questions. So every week there's a meeting called Global R&D. 100 plus people generally attend it. It lasts an hour and a half, and it's broken into segments that address different areas of the work we perform here. And people perform demos. They report on technical approaches they're taking, progress of other work, and so on. So this week we're going to dive into the forthcoming integration of the Internet Computer with the Bitcoin network. Now, this is really unlike anything else that's been done before in blockchain, and it's going to rely on this new chain key cryptography framework that powers the Internet Computer. So essentially, smart contracts on the Internet Computer are going to be able to control and maintain balances on the Bitcoin blockchain. And this is very, very different to the wrapping of tokens that you see in blockchain today. So for example, you can find wrapped Bitcoin on the Ethereum blockchain. And there are many ETH killer or so-called ETH killer blockchains that wrap ERC20 tokens from Ethereum. All of these things that you see today depend on something called bridges. Essentially, there's a bunch of trusted parties that act as custodian validators that say, look, if you want to bring some Bitcoin onto the Ethereum blockchain, send your Bitcoin to us and we'll issue you some wrapped Bitcoin on Ethereum. And then when you want to cash out, you send the wrapped Bitcoin to them and they give you real Bitcoin. The problem, of course, is trust. All of this wrapping relies upon trusted intermediaries, and it can go horribly wrong. Recently, there was such a service, it was called the Poly Network, that moved these different kinds of tokens between Ethereum and Polymatic and I think Avalanche, I'm not sure. And anyway, got hacked and $600 million worth of tokens were stolen. So we think, obviously, that's kind of a little bit antithetical to blockchain and there shouldn't be trust involved. And it's very important for tokens to move between blockchains without being at risk of theft. And we are applying a completely new approach based upon this technology we've developed called chain key cryptography. And it's essentially going to literally, in some sense, merge the Internet Computer and Bitcoin networks. Smart contracts on the Internet Computer are going to get balances of Bitcoin, and they're going to be able to send Bitcoin. But that's not wrapped Bitcoin. That's real Bitcoin on the Bitcoin network. So that'll mean, for example, that you could use something like OpenChat, which is a chat program that runs off the Internet Computer, and OpenChat might give you a balance of Bitcoin in your chat account, and you could send Bitcoin with chat messages securely, and the Bitcoin would actually move on the Bitcoin network if that's what you wanted. So the same technology will also be applied to integrate the Internet Computer with Ethereum, and there are actually lots of other applications of this technology too. We'll talk a bit more about that later on. So why don't we start off by watching an outtake from our Global R&D meeting that discusses this Bitcoin integration work. Okay, let's go.
It's my pleasure and an honor to present this nice feature today to our group. I'll share my own screen because I have some animations. Just switch over. Can you see my screen?
Yes.
Cool. Okay, so with Bitcoin integration, what do we want to achieve? So there's a couple of goals. First of all, to enable smart contract support for Bitcoin. So it means we can transfer Bitcoin to canisters. And we want to do so without any additional trust assumptions. And we want to make it as easy as possible to use for contract canister authors. So we go over
just stop there a second. Yeah, I just mentioned at this stage, the Internet computer has its own lingo. And we often refer to Internet computer smart contracts as canisters. And for the technically minded, that's because an Internet computer smart contract is a bundle of WebAssembly bytecode and persistent memory pages. And because a smart contract is this bundle of WebAssembly bytecode and the persistent memory pages that it runs within, we call it a canister. So whenever you hear the word canister, think a synchronous Internet computer smart contract. Okay, let's continue.
And there's essentially three problems we have to solve for this. So first, canisters can receive Bitcoin on the Bitcoin network. So they can be Bitcoin holder, like users. Second, canisters can be made aware of incoming transactions. And third, canisters can transfer out Bitcoin to either users or, of course, other canisters because they act like users. So those are the three problems we need to solve. But now first, let's go into how does Bitcoin work. Like if Alice wants to make a transaction to Bob, like this one here, she needs transaction inputs. And those inputs need to be so-called unspent transaction outputs of previous transactions, which means outputs of previous transactions which haven't been spent yet. And spending making a transaction means to spend those outputs. So that means the user needs to sign with their private key here in order to unlock those UTXOs, these unspent transaction outputs. And then, of course, the user also decides to whom it goes. In this case, to Bob, so accessible with the green key. And now this transaction is mined, if the user is lucky, into a block by the miners, and the block makes it into the blockchain, into Bitcoin blockchain. And if there's enough chain work in the form of other Bitcoin blocks on top of the block, then the transaction is deemed valid at some point. It takes an hour usually on Bitcoin. So now, what are the problems to be solved? Coming back to this, on the left side here, we have the Internet computer, one Bitcoin-enabled subnet, and here on the right, we have the Bitcoin network. And the most important part of this slide is the empty space in between here. So there's no trusted intermediaries, there's no bridges in between here. So referring to what Don made very clear yesterday also, no bridges. Now, what are the main, or what are the problems here? So coming back to those three problems, number one, canisters can receive Bitcoin. It means the canister needs to have a public EDCSA key and an associated private key or control this private key. This is the first prerequisite. The second problem is that canisters need to be made aware of incoming transactions. So this requires some means of getting Bitcoin blocks into the Internet computer in some way. Then validating those Bitcoin blocks, finalizing them, resolving forks. And once they're finalized, so there's enough chain work on top of them, we can extract a UTXO. And then the UTXO can be served to canisters. Then the canister can then use their UTXO, which they own and can spend again. They can use some ECDSA signing functionality using the private key they control. So it's a secret shared key, and we use threshold ECDSA for doing the signature. And
can we just pause there a second? Yeah. So for those of you that are unfamiliar, the Internet computer relies very, very heavily on threshold cryptography. So a chain key is actually a threshold key. So, you know, a subnet blockchain within the Internet computer network actually has a public key, but it doesn't have a private key. In fact, there's private key information shared amongst its nodes. And if a sufficient proportion of those nodes collaborate, they can create a signature for the chain key, the public key. The chain key cryptography framework is pretty extensive because, of course, any blockchain has dynamic membership. That means new nodes can join and old nodes and nodes can leave or break. So we deal with that using something called key resharing that enables these schemes to survive even though membership is dynamic. So when we're talking about smart contracts on the Internet computer having control of a private key. We don't mean they actually have a private key. What we mean is that they can call an API that instructs the blockchain as a whole to sign on their behalf. And this is obviously very important because we wouldn't want private key material residing on any one node, because whoever had physical access to that node might steal the private key and steal the Bitcoin. So whenever we talk about a private key, it's really a virtual private key that can be exercised by the blockchain as a whole. It's not actually a private key. Okay, let's continue.
And by this signing, we can then assemble a transaction and then send a transaction on an outgoing channel back to the Bitcoin network. And these two channels need to be built now. So that is a very high-level overview. And now comes a bit more technical view, but also on a very, very high level. So that's the technical architecture we have in mind on a very high level for the replica. So we want to run this Bitcoin functionality on every subnet which is large enough in terms of security, so sufficient number of nodes. And we have here some components in the networking layer, which I abstract here as a blob. And this blob pulls in Bitcoin blocks from the Bitcoin network directly without an intermediary, and it can send out Bitcoin transactions as instructed from the layer from the Bitcoin functionality here. This Bitcoin functionality, formerly known as the Bitcoin canister, we think now it's nicer in architecture from an architecture perspective to implement this as a system functionality if we want to run this on many subnets. It's better, nicer than implementing it as a special canister. So this Bitcoin functionality extracts the UTXOs from blocks, Bitcoin blocks, which have been validated, which have been finalized, and when there's enough hash work on top of the block. And this extracted UTXO can be served to canisters. And canisters can use their UTXO, so for which they control the private key, to make transactions, and they do so by using the ECDSA, the threshold ECDSA signing mechanism, which also cuts through the whole stack here, which Victor has presented last time, to make a signature on the UTXO and to consume the UTXO, and then the transaction being crafted is sent to the Bitcoin functionality, which relays it out through the protocol stack here to the Bitcoin network. So two notable points here. One is we are leveraging synergies with another feature, IC530, which is that canisters can make HTTP requests. And another important point is the direct integration. So again, stressing that we do not have any intermediary here. So it's really directly integrating the Internet Computer Protocol without any additional trust assumptions with the Bitcoin network. And from a perspective of team involvement, we have all the teams involved to a greater or lesser extent. And that's it from my side for this feature.
Thanks a lot, Peter.
So that's a high-level overview of how the integration with Bitcoin is going to work. I'm pleased to tell you that the chain key cryptography involved is already the work on developing that is already well underway. So currently the Internet computer relies upon BLS threshold cryptography. BLS stands for Bonnet, Lin, Strachan, and actually Ben Lin works at Dfinity. Dan Bonnet is a professor at Stanford. He heads up secure systems there. But Bitcoin, of course, uses ECDSA. So does Ethereum. So although we can, threshold sign BLS signatures, we can't currently threshold sign ECDSA signatures. So chain key cryptography is being extended so that we support threshold ECDSA cryptography and signing. And of course, there's much more to it than that, because we also need to implement key resharing protocols and so on that are specific to ECDSA. There's things like key derivation and whatnot going on too, so that each smart contract, each canister on the Internet computer will automatically get its own Bitcoin address or addresses. There's some things still to be decided, and that will enable people to send Bitcoin directly to Internet computer smart contracts. So, I mean, in some ways, what's so exciting about this is that we're actually extending the Bitcoin network with the world's most powerful smart contract framework. And that's a very interesting combination because, there's almost $1 trillion or maybe more than $1 trillion. I haven't looked at the price today, but $1 trillion of liquidity on the Bitcoin network. And that's now going to become available to smart contracts on the internet computer. And it's going to be fascinating to see what people build. And what's so extraordinary is there's no bridge and no trust involved whatsoever. These networks are going to directly integrate, and we're using the power of advanced cryptography to ensure that no trusted intermediaries are necessary. And you'll be able to move, write logic on the internet computer that moves Bitcoins around. So you can write smart contract logic on the internet computer that will actually move Bitcoin on the Bitcoin network. And that obviously is extraordinarily exciting. And I'm very proud of all the work that's ongoing to deliver this. And by the way, I should say that this is one of the unique things about the Internet Computer Project and especially the Dfinity Foundation. We employ an awful lot of cryptographers, and we employ this large team of cryptographers specifically so we can do this kind of thing. We also have all kinds of other experts in things like virtual machines and software and networks and data center architectures and things like that. So all comes together. But of course, at the apex, crypto is about cryptography, and I think we've got probably one of the biggest teams of cryptographers in the world, not just blockchain. So this integration of the internet computer and Bitcoin is really going to prove the value of that. Okay, so I'm going to throw it over now to Lamesh, who can ask questions on behalf of the community. Lamesh?
Hey everyone, this is Lamesh. I'm the Vice President of Growth at the Dfinity Foundation. I'm here helping build the developer ecosystem on the internet computer. So thanks, Tom, for sharing your thoughts. So one of the things as a foundation that we did recently is we shared our roadmap for what the team of our researchers, engineers, and cryptographers are working on over the next few months. And the topic that was very exciting, and we've been seeing an extraordinary amount of interest from the community, is the Bitcoin integration. I'll be taking a few questions with you, Dom, on what the community has been asking for. So one of the first thing that comes to mind is why Bitcoin? What's the advantage of starting with Bitcoin? Why not any other chain? And also when you look at this question, think in terms of what's the benefit to the Bitcoin ecosystem, as well as what are the different benefits to the internet computer ecosystem?
Okay, well, look, firstly, with respect to our choosing to integrate with Bitcoin first using chain key cryptography, don't read too much into the strategy, or there's no allegiances involved. The reason we tackling Bitcoin first is that it's a little bit simpler to do, and we also know that there's the Bitcoin protocol will stay stable for some time. So that's the reason we're pursuing a Bitcoin integration first. It's also fair to say that there's a vast amount of liquidity on the Bitcoin network, and effectively adding smart contracts to Bitcoin does have a lot of potential, and I believe we'll see some extraordinary applications of the combination emerging very quickly. So, for example, the internet computer supports this thing called internet identity, and that enables you to authenticate yourself to dApps running on the internet computer using a collection of devices that you've assigned to your internet identity. So, for example, you might create a Bitcoin wallet on the internet computer that loads into a web browser directly from the internet computer blockchain, because it can serve, smart contracts on the internet computer can serve interactive web content directly to users. And you would authenticate yourself using internet identity, which is an anonymizing blockchain authentication system, but it's very, very easy to use. Once you've added a bunch of internet devices to your internet identity, you can use any of them. So, for example, you might authenticate yourself to your Bitcoin wallet by pressing the fingerprint sensor on your MacBook Pro, or the equivalent on your Windows computer if you're using Windows Hello, or it might be Face ID, or for the paranoid, it could be a Ledger wallet, and you have to put the PIN in. Any of these approaches works. Now you're into your Bitcoin wallet, either using your fingerprint or your Ledger wallet, whatever your preference is, and now you can send Bitcoin to an address without actually without need to ever touch a key. So I could open my Bitcoin wallet by putting in a URL, authenticate myself with my fingerprint, and send some Bitcoin to a friend just by interacting with the wallet. And that Bitcoin would actually move on the Bitcoin blockchain. So that's pretty exciting, and I think people are going to start using Bitcoin within DeFi on the internet computer, and we believe that we're going to see the convergence of a lot of things. So in the future, we think social media and DeFi are going to converge. And so, for example, your wallet might actually be an account on a chat service like OpenChat, right? And that, not only will you be able to chat securely, but you'll be able to tip people with crypto, send crypto messages, negotiate sales, atomic transfers of crypto for NFTs within the chat, all kinds of interesting things. And Bitcoin is going to be part of this, new super advanced blockchain ecosystem.
So I take it as like Bitcoin is the first one because it was one of the easiest ones to start, but I think there are more integration that would be kind of coming as we over time. Yeah,
totally. I mean, integrating with Bitcoin is easier, for example, than integrating with Ethereum, because I'll just get to that in a moment. And the protocol's stable, so the work we invest up front isn't likely to be undone. But yeah, we also love Ethereum, so we want to directly integrate with Ethereum. There's a bit more work involved in that for two reasons. One is that in this case, there are smart contracts on Ethereum that want to be able to directly call, no bridges, remember. Bridges are antithetical to blockchain because they involve trust, right? So we want to directly integrate the networks so the smart contracts on Ethereum can directly call smart contracts on the internet computer and vice versa. And there are lots of applications of that too. So for example, today it's outside of the internet computer, it's impossible to create a real dApp. There's no such thing as a real dApp outside the internet computer. And the reason is that although you've got some smart contracts on the blockchain, people always have to interact with a website that's typically hosted on Amazon Web Services. So, what's happening today is that regulators and others are beginning to realize that these dApps aren't really truly decentralized. So, for example, Uniswap recently just had to delist half of the tokens on its service. A lot of these NFT websites are getting DCMA takedown notices because people are just saying, well, you say this is decentralized, but I'm not interacting with these smart contracts on Ethereum. I'm interacting with a website, and you've got your name on the Amazon Web Services account. Yeah. So on the cloud, right? So or on a server or whatever it is. And so with the integration, those DeFi services on Ethereum will be able to create their UI on the internet computer using internet computer smart contracts and truly decentralize themselves. The other part, of course, is tokenized governance, and they could continue with the way they're doing things. Or in principle, they could also use the forthcoming service nervous system functionality that the internet computer will support, which essentially allows people to reuse the network nervous system technology to govern their own dApps, and to allow the community to exert its will, configuring and upgrading these dApps. And in principle, rather than using governance tokens on Ethereum, they could use service nervous system on the internet computer. So you might see that Ethereum becomes a kind of DeFi settlement layer, and the user interaction and the governance exists on the internet computer, for example. So these are really exciting things too. So I think once we've tackled Bitcoin, we're going to look at Ethereum. Of course, one of the challenges there is that Ethereum's currently proof of work and it's planning to move to proof of stake. So we'd have to proceed very carefully to make sure that we didn't implement a whole load of Ethereum support in the internet computer network that then became obsolete a couple of months later. Because this is expensive, complex work that we're performing. The third application, actually, which is very important to mention at this stage, is X509 certificate support. So the network nervous system is intended to become a decentralized certificate authority amongst its many future roles. And this actually will depend upon the X509 threshold cryptography that's developed and indeed the whole chain key, supporting chain key cryptography framework. So, this work we're doing is actually going to bring a whole load of features into play. We're going to extend Bitcoin by giving it smart contracts, or vice versa, depending how you look at it, giving internet computer smart contracts Bitcoin balances and control over Bitcoin, direct control over Bitcoin that live on the Bitcoin network, is going to allow us to integrate with Ethereum. So smart contracts in Ethereum can call smart contracts on the internet computer and vice versa. And it's going to allow the network nervous system to become a decentralized certificate authority. For those of you who don't know, certificates are very important because they're involved in HTTPS. So when your web browser makes a secure connection to a DApp that's hosted on the internet computer, and you see that lock symbol in the address bar, we're going to be making it possible for people to use friendly domain names on the internet computer, because at the moment you get this arcane domain name when your DApp is on the internet computer. You'll be able to have friendly domain names, and it's going to work with HTTPS, so you're going to see the lock symbol. And there are various other reasons we want to do it too, which are quite technical. I won't get into here. So this work that we're doing right now to bring to integrate the internet computer and Bitcoin, that work also supports other stuff and makes the further steps to Ethereum and X509 very, very short.
No, it's good to hear that all of these progress that we are making for the Bitcoin and internet computer integration, there's like a lot of these components that would help us enable lots of different things in the future. Now, one of the things, and again, you talked also earlier in the presentation, is this concept of bridges, right? Which, I mean, if we look at the blockchain ecosystem and what are the different chains have been doing, they have been adopting this concept of like building a bridge between the two chains. So the question is like, what makes the internet computer unique in terms of like being able to integrate directly with Bitcoin, what all of these other chains haven't been able to do so far, and they've been relying on these bridges. So what are the downsides of bridges? As you explained, there's like different trust assumptions, as well as I think what makes the internet computer unique so that we are able to tackle it in a very different way versus any other blockchain that have attempted in the past.
Well, look, for those viewers who don't know about the history of the internet computer, I mean, it's Dfinity is one of the oldest original gangster projects. It's just that we took a very long time to get this internet computer out because there was so much R&D involved. The internet computer project involves by far the biggest R&D operation in blockchain. There's nothing like it. And we employ the world's biggest team of cryptographers outside of perhaps the NSA. I don't know how many they employ, but what we do is very non-trivial. And look, we believe very much in something called blockchain singularity. Our objective is to create a real world computer upon which everything can be built using smart contracts. So we want people to throw away traditional IT, which costs the world about $5 trillion a year. Throw away traditional IT, throw away your cloud services, throw away your servers, throw away all that stuff, and let's rebuild everything using smart contracts on the internet computer, which run on a public network, are tamper-proof, unstoppable, it can be composed, allow systems to be composed, support autonomy so we can do tokenization and create viral growth flywheels and microeconomies and token incentive schemes and all of that, and decentralized value, all of that stuff. I'm a firm believer that within 10 years, decentralized finance will be bigger than traditional finance. Obviously, we'd like that to be running on the internet computer and other blockchains that we integrate with. We want all of these kind of online services that are so crucial to our lives, like social networks, for example, and chat systems, and the commercial versions of those things like Salesforce. All of these things need to be rebuilt as dApps, which are tokenized, which allow users to become owners, also the team helping with things like moderation, and fundamentally create richer experiences because they're more open and lots of developers can participate in extending them and the blending of DeFi and things like social media create far richer experiences too. So, we're sort of blockchain maximalists, if that makes sense. We believe in blockchain singularity and we're blockchain maximalists. And for us, decentralization isn't a buzzword that's used to create hype and pump token prices, which, truth be told, it can be today. So, when we look at things like bridges, our heart sinks a bit because we know that they involve trusted intermediaries. And, for example, today people are very happy using wrapped Bitcoin on Ethereum. But, I think there's a couple of $1 billion worth of Bitcoin on Ethereum. It's not nearly as much as there should be because people recognize that in order to get their Bitcoin onto Ethereum, they have to give it to this organization that's doing the wrapping. There's a trusted intermediary. And, in its own way, this is just as bad or worse than Mt. Gox, if you remember all that back in 2014. I certainly lost some money on Mt. Gox. So for those of you who haven't been in crypto that long, this was a Bitcoin exchange in Tokyo that got hacked over a long period of time and all the Bitcoin disappeared. Or some say, this guy running it took it. But, we just saw the Poly network got hacked and $600 million worth of these crypto assets went missing and were stolen. Albeit, I think the thief has voluntarily returned them. Very nice of him. But, clearly this isn't the way to go. And the latest thing, of course, is you've got all of these sort of ETH killer blockchains that have just, reusing the EVM so you can copy paste Ethereum smart contracts onto these networks. They're doing these deals that they're giving loads of tokens away to the teams who create these DeFi systems, saying, look, if you copy paste your systems onto our networks, we'll give you all these tokens, and it pumps their token price and blah. But what people should know is that all of these systems are depending on these bridges. When you move tokens from Ethereum onto sort of Avalanche, say, or something like that, you're sending your valuable ERC20 tokens to some trusted intermediary. And yes, they can turn evil and steal your tokens. Yes, there can be a technical problem and they can get hacked, and all your tokens can be stolen. And that's kind of antithetical to blockchain, right? I mean, there are lots of other things that are antithetical to blockchain that are very common today. Another one, of course, is the fact that dApps really run in the cloud, right? I don't like that. I don't like the fact that whenever you interface with an Ethereum dApp today, you're not really interfacing with a dApp at all. You're interfacing with a website on Amazon Web Services. I mean, that to me is pretty bad. Like Web3 means end-to-end decentralization, right? Why the hell can't these blockchains, advance a bit and be a bit more like the internet computer and serve user experiences directly to users too? There are other things I don't like. A lot of these proof-of-stake networks run entirely in the cloud themselves. Like all of their cloud instances, all of those validators are running on mostly Amazon Web Services. And Jeff Bezos could steal their validator keys anytime he wanted, corrupt the chain, steal stuff, turn them off, whatever. And as you know, for that reason, the internet computer is hosted by dedicated node machines that are run by independent node providers from independent data centers. There's absolutely no cloud involved whatsoever, and it's designed in such a way that you can't make use of the cloud when running a node. So there are lots of things we feel that happen in blockchain today that probably shouldn't happen. But look, I mean, this integration with Bitcoin is addressing one of them. When internet computer smart contracts interact with Bitcoin, they're actually interacting with real Bitcoin on the Bitcoin network. And they've been blended together using chain key cryptography. And we think this is a really big advance because, look, there's $1 trillion of liquidity on the Bitcoin network. And in a few months' time, Bitcoin developers are going to be able to write smart contracts that manipulate that liquidity. They were, and anybody, by the way, like Lamesh, you could write a smart contract on the internet computer, and it will have an address, and I could send Bitcoin from my Bitcoin wallet to your smart contract, and that Bitcoin will move on your Bitcoin will move on the Bitcoin blockchain, and will be controlled thereafter by your smart contract. That's incredible. Yeah, and then once we've done that, we'll move on to Ethereum, and then the same thing will work for ERC20 tokens. So it's super exciting.
Interesting. So I think one of the interesting terms you brought to earlier in the conversation was we are blockchain maximalists. So this is one integration where we have something for both the Bitcoin maxis and the blockchain maxis, because we are basically integrating the two chains together. So I think, Dom, it's almost time for us to wrap up. But I think before we go, I think one of the things that I would like you touched upon briefly in terms of this vision that we have of blockchain singularity. So would love to share more light with our audience in terms of what do you mean by that? Is that just about the internet computer? Is that about other chains? What is the vision of this blockchain singularity that we have?
Well, look, I mean, our vision is that everything, or just about everything, every service, every system, backend system runs off public blockchain. Look, I mean, I've been around a bit. If you go back to the 1990s, I remember this debate in which, America Online and CompuServe were saying, hey, we carefully curate the services and content that users can access it. It's a much safer environment, and promoted that sort of vision of private, walled gardens, as they're called. And then Microsoft, I believe, proposed something called the information superhighway, and they said to the government, look, you don't want to let everyone loose on the internet. God knows what might happen. Look, give us a contract and we'll build this information superhighway and make sure it's safe. Look, thank God none of that happened. Like, in the end, everybody chose the free, open, and permissionless public internet, right? And I think exactly the same thing is going to play out with, traditional legacy tech versus blockchain. People are going to want to build on public networks rather than on Amazon Web Services, say. It's inevitable. Now, there are lots of, all things being equal, public networks would already win for the same reason the internet beat out AOL and CompuServe and the information superhighway didn't happen. Of course, nobody wants to be a captive customer and build on a closed proprietary environment run by some megacorp. Nobody wants to do that. So all things being equal, people would already choose to build on blockchain. But look, blockchain has much bigger advantages than just being open. Blockchain supports smart contracts. Only a decentralized network composed of independent participants can support smart contracts. And smart contracts are a new form of software that are vastly superior to any other form of software that's gone before. Smart contracts, as we just mentioned, run on public networks. Smart contracts are tamper-proof. They always run the correct code against the correct data. So you don't need a firewall to protect them. And today, by the way, traditional IT is in meltdown. Look at the SolarWinds hack. Look at the Colonial Pipeline hack that left the eastern seaboard of the United States without gasoline. Smart contracts are tamper-proof. You can't encrypt them with ransomware and so on. Smart contracts are unstoppable, just like the internet itself, which is very important. Smart contracts, as I mentioned, are a new form of software. They're both software and systems at the same time. So when you build software, you only write the code that's unique to your own application. And then you link in libraries of pre-existing code that's already been written. So you build software from components. Smart contracts enable you to build systems in the same way. You can compose services from existing smart contracts. And each smart contract can also be a part of multiple services at once. So this is absolutely extraordinary. Of course, you can also make smart contracts autonomous. And once they're autonomous, controlled either non-upgradable or controlled by tokenized governance systems. Once smart contracts are autonomous, you can introduce tokenization, and tokenization supports decentralization of value, microeconomies, viral growth flywheels, and all these other things. So when you put that together and you see the simplification smart contract technology provides when you're developing systems. And you realize that because any smart contract can plug into any other smart contract on the same blockchain, that there are going to be these immense network effects. You realize that blockchain singularity is absolutely inevitable once the limitations of smart contracts are removed. And back in 2014, I was introduced to this idea of the world computer as part of the Ethereum community. And when I heard this idea, I thought, wow, there has to be a real world computer, right? Not a sort of a world calculator, a world computer with infinite capacity, right? And I saw that smart contracts were really something very different. I've been coding for decades, and this was a new form of software. And I realized that smart contracts just have immense power. And so I said, well, imagine if there's a real world computer with unlimited, unbounded capacity that ran at web speed and that could also serve interactive content directly to users. If it could run efficiently enough, even run with efficiency approaching traditional IT. Well, if you could remove the limitations from smart contracts, blockchain singularity is inevitable. Everything's going to get rebuilt with smart contracts. And I do believe, people will move from traditional IT to public blockchain and build with smart contracts. But what's so exciting is that, smart contracts are such a different form of software that when we rebuild everything with smart contracts, we will also reimagine it. And, very obviously, DeFi looks very different to traditional finance, right? And in the future, you're going to see social media gets reimagined too, and it's going to blend with DeFi. And so it's a very exciting new world coming.
And very interesting in terms of when we are talking about the software, we're not talking about just like simple DeFi systems. We are talking about reimagining every form of software that's known to mankind, whether it's enterprise systems, social media, DeFi, like the NFT space, pan-industry systems. So it's basically a blend of everything that could be reimagined and rebuilt using a blockchain. So great. Thank you, Dom. It was really fascinating.
Thank you. Everything rebuilt and reimagined on blockchain. That's blockchain singularity, and it's absolutely inevitable because of the huge advantages that smart contracts provide. Yeah.
Awesome. Thank you, Dom. It was a pleasure being here with you.
Yeah, thanks, Lamesh. Pleasure.